Do you know the muffin man who lives on Drury Lane? You're running a muffin shop. Before the store opens, you bake a batch to get ahead. After that, you only bake more when inventory starts running low. Bake too much, and muffins sit unsold. Bake too little, and customers show up to empty shelves. When should you start baking again? And how much inventory should you keep ready? How do you balance production with customer demand? There's a model for that. Welcome to Model Monday, a series where we break down scenarios in different industries, organizations, and departments, and explain how you can build a simulation of them in Process Playground. Let's model it. The first thing we'll do is create our items. So we're going to create a muffin, and then we're going to create a muffin batch. We're going to set it so each batch contains 12 muffins. Now that we have our items, we can start building out the process. Let's start with our customers. This is going to be a pull system, so we're going to have our customer demand at the end of the process. Let's pull out a demand block and call it customer demand. We're going to have some startup time before our shop opens up for the day, so we'll have our customers start buying muffins at time 120. By changing this parameter, we can keep this demand block off until that time. We'll also close up shop before the end of the simulation, so we will have our customer demand end at time 440. Customers will get their muffins from a block called the pull block. This block will manage our inventory and call to bake more muffins. We'll add the muffin item to this block, but we'll set the parameters for it later. Now, let's stock the pull block with muffins from our baking process. We'll start with a demand block and rename it Forecast by Batch. We do not want this block creating muffins individually. So let's get rid of the muffin item and add the muffin batch item. We're going to say we'll create a muffin batch every 30 minutes. We're also going to end this initial forecast at time 121. This gives us 4 batches to begin our day. Next, we'll connect that to a queue block and rename it Pending Batches. This gives us a place for batches to wait before they move into production. From there, we'll add an activity block and name it Mix. This represents mixing up the batch of muffins. The processing time is going to be 5 minutes, and in this case, we're just going to leave it as a constant distribution. If your own process has more variation, you could always change that later. After that, we'll add another queue block. Then we'll add another activity block and name it Bake. We'll say we have 2 ovens, so we'll set this block to have 2 servers. Again, we're going to say a time to produce a batch is constant, and it'll be 25 minutes. Now that the batch has been baked, we'll add a split block and connect it to the other blocks here. This is where we'll split the muffin batch into individual muffin items, so we'll add the muffin batch item to this block. Great! Now we've established the process for the beginning of the day, but how about refilling our supply throughout the day? Before the pull block can work correctly, we need to define where that replenishment signal is going. So we're going to establish a new queue block and rename it Muffin Restock. Then we'll add a kit block and connect it to our pending batches step. Make sure to add the muffin batch item to this block. Now we can go back and fill in the pull block settings. We're going to pull muffins. We'll have 0 on hand initially. We'll have a system max items of 24 muffins, and the trigger point will be 12. The target queue will be Muffin Restock. At this point, the model is complete. We'll take a short detour to talk about formatting your model. If you are in pan mode, you can hold down Shift and you will get a pointer. If you click and drag with the Shift held down, you will select multiple shapes at one time. Then you can move them all together. You can also select multiple shapes and then right-click on one of them to open a menu where you can align them. In this case, we picked middle to make sure they are straight across. You can also distribute them evenly from this menu. As you're dragging shapes, you might also notice the red lines which allow you to snap them to other shapes. Now let's run this model and see if everything is working the way we expect. We're going to run the model for 500 minutes. At first, we can watch the batches being produced and moving through the system, and see the muffins building up in the pull block. Once customer demand begins, we start selling them, and we start seeing the pull block reduce the number of muffins that it has available. Once it hits 12 muffins, it orders a new set from Muffin Restock, which immediately moves into the kit block. Once it leaves the kit block, it moves through the process as a muffin batch. Now let's take a look at the chart. The main outcome we're interested in is how are we doing on inventory over the course of our simulated day. Let's take a look at the queue length chart in our pull block. We can see that the overall trend over the course of the day is going down, but we reach the end of the day before running out of muffins. We do currently run more muffins than we need toward the end of the day, but we can use this chart to make informed decisions about our scheduling. So in a nutshell, that's the muffin shop model. But the real value is in what you can experiment with. By modeling inventory that is replenished based on customer demand, you can see how different reorder points and batch sizes affect availability, waiting, and excess inventory. And it's not just muffin shops. The same pattern shows up in restaurants preparing food ahead of demand, warehouses replenishing inventory, hospitals restocking supplies, or manufacturing systems producing batches to maintain inventory levels. From here, you can start to ask real design questions. When should I trigger another batch? How much inventory should I keep available? What happens if demand increases or production takes longer than expected? Those are the kinds of trade-offs this model is built to explore.
That's the model. Now go experiment. Happy modeling!